Your MCP implementation is connected, authentication is working, the tools are responding, and your AI is returning confidently wrong answers about your data. Wrong table names, wrong owners, wrong definitions. Because 70% of your catalog has no descriptions, no certifications, and no assigned owners. The connection succeeded, the context failed. And here's the uncomfortable part. Most teams will spend the next 6 months debugging the AI model, tweaking prompts, and evaluating different MCP servers, when the actual problem is the metadata sitting behind the server they already have. The MCP implementation decision isn't a DevOps problem wearing a data questions clothes. It's a metadata governance decision wearing a DevOps costume. And until teams see it that way, they'll keep building integrations that work technically and fail practically. We've watched teams spend weeks selecting MCP servers, configuring OAuth flows, and verifying tool responses. And then launch AI assistants that immediately surface deprecated tables, suggest columns with no business definitions, and confidently recommend assets that were archived 2 quarters ago. The integration was pristine. The context was the liability. The dominant view on MCP implementation is reasonable. MCP is a protocol, a universal standard for connecting AI clients to systems, designed to work across Claude, Cursor, ChatGPT, Gemini, Copilot, and a dozen other clients. When something's designed as a protocol, the natural question is, which implementation do we use and how do we configure it for our stack? So teams approach the decision the way they approach any integration decision. They inventory their AI clients. They find the setup guide that matches each one. They evaluate servers on connection stability, authentication method, and client compatibility. They run a pilot, verify that tools respond correctly, check that authentication holds, and declare the implementation successful. Then they standardize. One approved server, one authentication pattern, documented setup instructions rolled out to the team. This isn't an unreasonable approach. It maps directly onto how enterprises have managed every other connectivity layer. JDBC drivers, REST connectors, API gateways. Pick the connector that speaks to your system, validate the connection, govern through access control, and move on. And it has genuine cost advantages. A team that treats MCP as a routing problem, match AI client to setup guide, configure done, can ship an implementation in just days. The complexity is real but bounded. OAuth flows, token scoping, firewall rules. These are solvable problems with documented solutions. Treating an MCP as infrastructure you configure once and stop thinking about isn't naivety. It's efficiency, given what the protocol's own framing invites you to believe about it. The failure mode isn't that this approach is careless. It's that it optimizes for the wrong variable. Connection success is a necessary condition. It's not a sufficient one. And the gap between those two things is where MCP implementations quietly collapse. Consider what actually happens when an AI agent sends a query through an MCP server to a data catalog. The agent asks, which table should I use for monthly revenue by region? The MCP server receives the query, runs a semantic search against the catalog, and returns the assets that best match. But what determines which assets surface? It's not the quality of the MCP connection. It's not the authentication method. It's not the server version. The quality of the metadata attached to each asset is what it is. Specifically, whether the asset has a description that uses revenue related language, an owner who can be identified as responsible for it, a certification status that signals it's been validated, and linkages to glossary terms that establish what revenue means in that organization's specific context. If the catalog's assets have none of that, if they're tables with technical names, no descriptions, no owners, no certifications, the semantic search has nothing to work with. It pattern matches on whatever language exists. Column names, schema names, the actual raw technical identifiers that data engineers chose when they built the pipeline. The AI returns an asset. The asset may be completely wrong, but it's returned with the same confidence as a result that was perfectly documented. Now, this isn't a failure of the AI model. It's not a failure of the MCP server. It's a context quality failure, and the connection focused implementation decision has no mechanism to surface it. A team that evaluated their MCP implementation by verifying that tools respond to test queries will have seen green check marks all the way through, a process that left the actual quality problem completely untested. The second breakdown is subtler and actually compounds over time. Teams that standardize on a single AI client, we use Cursor, so we configure MCP for Cursor, discover that client preference isn't uniform. Data engineers reach for Cursor, analysts work in ChatGPT or Claude, and business stakeholders use Copilot or similar embedded tools. When an organization standardizes on one client for governance simplicity, it hasn't simplified governance. It's just excluded every user whose workflow doesn't match the chosen client. The governance work hasn't been done. It's been avoided by narrowing the population of users who can reach the system at all. Here's the sharper version of that point. Permission requirements don't vary by client. An analyst who's permitted to see finance data in one tool should be permitted to see it in every tool, and equally shouldn't be able to see data they're not permitted to see regardless of which tool they're using. When governance is implemented by restricting which clients can connect, rather than by enforcing permissions at the server level, you have governance that dissolves the moment someone connects a new client. That's not a governance model. It's a workaround that will fail exactly when scale makes it most expensive to fix. Now, the third breakdown is organizational, and therefore it's the hardest to see. MCP implementation gets categorized as a DevOps task. Configure the server, set up authentication, verify the connection, hand it off. The question of who's responsible for the quality of what the server exposes, the descriptions, the certifications, the ownership records, the glossary linkages, falls outside of the scope of that task. No one's assigned to it because the implementation decision never surfaced it as a requirement. The server gets deployed. The catalog behind it is undocumented. The AI is confidently unreliable. And the organization has no model for why because it never asked the question that would have made the answer visible. Here's the mental model that resolves all three of these breakdowns. The MCP implementation decision is a metadata governance decision, and the quality of the context the server exposes is the only variable that determines whether AI agents built on MCP are trustworthy. Everything else, which server, which client, which authentication method, is infrastructure. Infrastructure is necessary. Infrastructure alone is not sufficient. The substantive decision isn't which MCP server connects to our catalog, but is the context our MCP server exposes good enough to ground AI decisions responsibly? This reframe changes what you measure, what you build first, and who owns the outcome. Under the conventional view, MCP implementation success looks like connection established, tools responding, authentication verified. Under the reframe, success looks like the assets AI agents are likely to query have descriptions, have assigned owners, have been certified or explicitly flagged as uncertified, and are linked to the glossary terms that give them business meaning. The technical infrastructure is table stakes. The context quality is the actual product. One concrete way to see this, imagine two organizations running identical MCP server configurations, both connecting to data catalogs from the same vendor. Organization A has invested 18 months in metadata enrichment. Every critical table has a description written in business language, a certified owner, linked glossary terms for every key metric. Now, Organization B deployed the catalog 2 months ago, documented a landing table, and they left the rest for later. When both connect to AI agents through MCP, Organization A gets agents that find the right assets, route questions correctly, and surface trustworthy results. Organization B gets agents that retrieve technically connected but semantically wrong answers, and analysts who stop trusting the AI within 2 weeks of launch. The connection quality is identical. The AI quality is not. The difference is entirely in the context layer. What does this reframe require that the conventional approach didn't? It requires that metadata enrichment be treated as an MCP implementation prerequisite rather than a future state improvement. That's genuinely harder than configuring a server. Enrichment is an organizational process. Someone must own each asset, someone must write descriptions, someone must certify the canonical tables. These aren't DevOps tasks. They require the cooperation of data owners, business stakeholders, and governance leads who may not have been consulted during the MCP setup process. But the trade-off is real. Treating MCP implementation as a governance question is slower and involves more stakeholders than treating it as a connectivity question. But the alternative is an AI that's fast and wrong, which is worse than an AI that doesn't exist yet, because it trains users to distrust the system before it's had a chance to even earn their confidence. The most direct evidence for this reframe comes from how MPC search quality actually behaves, and the documentation describing it is unusually candid about the mechanism. When an AI agent queries a data catalog through MCP, the server runs semantic search against the catalog's asset. Search quality depends on whether the language in the query matches the language in the asset's metadata. An asset with no description gives the search engine nothing to match against except for its technical name. An asset with a rich description, linked glossary terms, and a certified owner gives the search engine multiple matching surfaces. The difference in retrieval quality between those two states isn't marginal. It's the difference between returning the right asset and returning the most technically named asset that happened to share a word with the query. Now, the structural point. MCP's core design lets a single server serve multiple AI clients simultaneously. One well-governed catalog exposed through a single Atlan MCP server can serve Claude, Cursor, ChatGPT, Gemini, Copilot, Databricks, Snowflake Cortex, and others. Same connection, same permission model, enforced identically for each. That's not just a feature. It's proof that the standardization question belongs at the server in context layer, not at the client layer. When the context is governed, client diversity is solved automatically. When the client is standardized without addressing the context, the wrong question has been answered. The third piece of evidence is a specific documented failure mode. When a user connects an AI client to an MCP server and the server can't find an assigned persona for that user because the persona assignment was skipped during implementation, the user session has no data access scope. The AI client is connected, the tools respond, but the results are empty or incorrect because the permission model was never configured. This is exactly the failure that emerges when MCP is treated as a connectivity task. Authentication was completed, but the governance step, assigning the user to a persona that defines what they can see, was never recognized as part of the implementation. And there are numbers. There's documented evidence that investing in the context layer produces measurable improvements in AI accuracy. One published proof point shows a 9x improvement in AI use case accuracy following investment in metadata enrichment. Those figures can't be attributed to MCP configuration quality. The MCP server setup is the same in both states. The variable that changed was the richness of the metadata the server exposed. That's the argument made concrete in a number. If the MCP implementation decision is a metadata governance decision, several things change about how teams structure the work. First, the question, are we ready to implement an MCP, becomes equivalent to, is our metadata ready to be the context layer for AI agents? Now, these aren't sequential decisions. Implement MCP, then improve metadata layer. They're simultaneous ones. A team that launches MCP on an undocumented catalog doesn't have a working AI infrastructure that needs improvement. It has a liability. An AI that generates confident, fast, wrong answers, training users to distrust the system before it's been given a fair chance. Second, the person responsible for MCP implementation success isn't the engineer who configured the server. It's the data owner who certified the tables, the governance lead who assigned the personas, the business analyst who wrote the definitions that let semantic search find the right asset. The DevOps work is necessary. It's just not the work that determines the outcome. Now, third, the evaluation criteria shift from technical to contextual. Teams don't declare implementation success when the connection is green. They declare success when the assets most likely to be queried by AI agents have been documented to the standard that makes retrieval trustworthy. That's a harder bar to hit, but it measures what actually matters. Fourth, client proliferation stops being a governance problem. Under the conventional view, each new AI client that wants to connect to enterprise data means a new integration, a new authentication setup, a new permission configuration to maintain. Under the reframe, a new client is just a new interface to the same governed context. It inherits the permission model, the certified assets, the enriched descriptions, without requiring any new governance work. Adding a new AI client takes hours, not weeks, and introduces no new governance risks. The first question to ask isn't which MCP server should we use. It's what would an AI agent ask about our data? And does the metadata behind those assets give the server enough to find the right answer? That's a diagnostic question that teams can actually answer this week without changing any infrastructure. Find the 10 tables or datasets that AI agents in your organization are most likely to be asked about. The revenue table, the customer dimension table, the product catalog. Open each one in your catalog. Check whether it has a description written in business language. Check whether it has an assigned current owner. Check whether it's been certified or explicitly marked as uncertified for a documentation reason. Check whether it's linked to the glossary term that would appear in a natural language query about it. If the answer to most of these questions is no, the actual MCP implementation problem has been found. And it's been found before deploying AI agents that will make that problem visible to users in the worst way possible. The first decision to make differently: treat metadata enrichment as a pre-launch requirement for MCP, not a post-launch improvement track. Assign ownership to the assets in scope for AI queries before the AI client is turned on. Write descriptions before the first demo. Certify the tables that AI should recommend so the trust signal exists when the query arrives. The longer path, what this looks like 6 months from now for a team that's genuinely adopted this reframe, is that metadata enrichment in AI infrastructure becomes the same conversation. Teams that have made this shift report that every new AI use case starts with a metadata audit. Which assets are in scope? What enrichment is required? Who owns the certification? The MCP server is already configured. The work is always on the context. And because the context is governed, every new AI client that connects inherits a system that's already trustworthy, not one that needs another round of debugging before users will actually believe it. The MCP implementation decision is a metadata governance decision. And the sooner teams see it that way, the sooner they stop debugging the AI and start fixing the actual problem. But that raises the next question. Once you've committed to governing the context layer, how do you enrich metadata at the scale that enterprise AI demands without it turning into a years-long manual project? That's a different problem, and it has a different answer. We'll get into that next.